Hello everyone. So in class we've been talking about how you plot rational numbers on the number line. So rational numbers are numbers that are integers or mixed numbers or terminating and repeating decimals. And they are all really easy to get on the number line, and we've learned how to do that. Today I'm going to talk to you about something a little bit more challenging, which is how to get irrational numbers on the number line. So irrational numbers are numbers that cannot be written as a fraction, and they are non-terminating and non-repeating decimals. So some examples that we know about of irrational numbers are pi, which is the number 3.14159 blah 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 on forever. Another popular one is e, which is used a lot in business and also in the natural world. This number comes up a lot. And finally, any square root that is not a perfect square is an irrational number. For example, the square root of 5 is not a perfect square. 5 is not a perfect square. So this number will be a non-repeating, non-terminating decimal. We also have square root of 2 and any other square root that's not a perfect square. Square root of 11, square root of 107, all will be irrational numbers. So today I'm going to talk about how to get some of these numbers onto the number line. And to do that, we have to think about what rational numbers are these numbers near. To start out, we've got pi. It's the first one we're going to do. So pi is the number 3.1415926, and it goes on forever, and it doesn't repeat, and it doesn't end. But the number 3.1415926, right, is going to be somewhere near the number 3.1. It's actually going to be a little bit bigger than 3.1 because we have all of these extra decimal places going on. So we're getting a little, it's 3.1 and then another 400th and another 1,000th and another 5/10,000. So it's a little bit bigger. Pi is a little bit bigger than that number. So pi is bigger than that number. We also know in that case, but pi is going to be less than 3.2 because it doesn't quite get to that place. So our number pi is going to be somewhere between 3.1 and 3.2. So let's put that on the number line. We'll put it in between those two numbers. So 3.1 as a fraction is, or a mixed number, is 3 1/10, and 3.2 is 3 2/10. So pi has to fall in between those two numbers. So let's get some tenths going between 3 and 4. To do tenths, we could do fifths, so 5 equal spots, and then cut those in half, and that gives us our tenths. So here is 3.1, and here is 3.2, so pi is going to be in between those two numbers. That pen doesn't work, let me try another. There, in between 3.1 and 3.2, or 3 1/10 and 3 2/10 is going to be pi. Let's do e. So to put e on the number line, we need to know its decimal version. And so e is about 2.71. I think it's a 4, and then it keeps going. So we know that e is going to be bigger than the number 2.7 because it has more decimal places, but it's also going to be smaller than the number 2.8 because it doesn't have 8/10, so it's going to be smaller. So similar to with pi, we can take this number and write it as a mixed number and figure out where it is on the number line. So this is the number 2.7 is 2 7/10, and 2.8 is 2 8/10. So e is going to go somewhere in between those two numbers. So again, between 2 and 3, we'll make our tenths. Cut it into 5. Cut each of those in half. We got 10. Find 2 and 7 tenths. So 1, 2, and 1, 2, 3, 4, 5, 6, 7 tenths. And so that's 8 tenths. And so E is somewhere in between here. For our purposes, it's okay to get it within a tenth of where it actually is. That's a pretty good estimation. So we take our irrational number and figure out 2 rational numbers that are right next to it, and we can put it in between.